Hello everyone. Today we are going to look at section 4.3, which is on Newton's third law and normal force. And so our learning target today is to identify the effects of Newton's third law. And our two questions are, what is Newton's third law? And how is normal force related to weight? Alright, so let's start with some review because, well, that's how we always start. And just remember that a force is a push, a pull, or a twist. And remember that all forces, that's an S, are measured in newtons. Alright, so if you ever see anything labeled with an N, you know that has to be a force because that's what we use to label newtons, or to label force. Newton's first law, this is a long time ago, but remember Newton's first law says that an object's motion won't change, right? So if it's just sitting there, it's going to keep sitting there. If it's moving, it's going to keep moving. So all motion is constant, moving or not moving, unless there is an unbalanced, you might also hear it called outside force, an unbalanced force. So remember we talked about bowling balls, right? That bowling ball is just going to sit there unless you do something to it, unless you push on it or something. Okay, Newton's second law. This is our formula. Net force is equal to mass times acceleration, or if you want to talk about weight, we could say Fg is mg. Or if you want to talk about apparent weight, you can have m times g plus a, all right? But essentially it's always the mass times some kind of acceleration. All right, here's our new stuff for today, Newton's third law. Newton's third law says all forces, let's try that again, there we go. All forces come in pairs. You might have heard this as every action has an, you've heard this before, right? Equal and opposite reaction. All right, so if there's an up force, there has to be a down force. If there's a left force, there has to be a right force. Sometimes they're a little bit hard to find, but every action has an equal and opposite reaction. Forces come in pairs. All right, so what does that mean? Well, that means if we take our first example here, this person is stepping off a boat. So think about this. If the person steps to the left, they're pushing on the boat, right? So the boat is going to push back on the person. Person's going to go one direction, the boat's going to go the other direction. So let's say that this person is pushing, we have a pushing of 10 newtons to the left, okay? Then the boat is going to experience an equal pushing force. So this is the push of the person on the boat, and this is the push of the boat on the person. Okay, equal and opposite. It's also going to be 10 newtons. Hey, wait, why did I make it negative? Good for you. We made it negative because it's going in the opposite direction. Okay, so if I have 10 newtons to the left, I have negative 10 newtons to the right. Equal and opposite. Okay, let's take a look at the second example here. So in the first and the top panel, we've got this person who is pulling 50 newtons to the right. So I've got a pulling force of 50 newtons to the right. That means that the wall doesn't actively pull, right? But the wall still exerts a force. So this is a pulling force of the wall, which is going to be negative 50 newtons to the right. Equal and opposite. What about if we don't attach it to a wall? What if we attach it to an elephant? Same thing, right? This pull is still 50 newtons to the left. This pull is still 50 newtons to the right. So we call it negative because we have to show that it's in the opposite direction. Okay, equal and opposite. All right, so what about this example? So where are my equal and opposite forces here? Well, I have the force of gravity going down, right? The attraction between the book and the earth. But the books can't actually fall toward the earth because the table's in the way. So I have an upward force of the table on the books. All right, so we would call this downward force, of course, is our force of gravity, and the upward force is the force of the table on the books. Agreed? They're going to be equal and opposite. So if we make this table force 15 newtons, then we have to make the gravitational force negative 15 newtons because it's going in the opposite direction. Alternately, you could make the up force negative and the down force positive, right? As long as you're showing that they're in opposite directions. Okay? All right. So I'm going to stop here for just a second. Newton's third law. All forces come in pairs. They have to be equal in size and opposite in direction. Or every action has an equal and opposite reaction. So pause for a minute, look that over, and make sure you're comfortable with that. Okay. So what about this idea of normal force? Well, normal force is really just a special name for the force that's opposite gravity. Okay? So this is the force that is opposite gravity. So we could say that the normal force is equal and opposite to the gravitational force, right? Because they'll be the same size, the number will be the same, but the direction will be different. Or you could write it as negative normal force is equal to positive gravitational force. It really doesn't matter. We do usually make the gravitational force negative because it's going down. So we usually do it that way. But you could do it the other way. All right, so let's do an example here. So what have we got? We've got 3 books. They're all sitting on top of each other, and they're sitting on top of a table. So each book is pushing down on the book below it, and all 3 of them are pushing on the table. Well, if you have a down pushing force, you have to have an up pushing force, right? So let's see if I can make this stand out a little bit better. If this book has a downward force of 5 newtons, or we could call it negative 5 newtons, then there must be an upward force also of 5 newtons, and that's what we would call the normal force. Okay, does that make sense to you? All right, so let's see what this asks us over here. How much gravitational force does the red book exert on the blue book? Okay, well, the red book's on top and the blue book's in the middle. So the gravitational force of the red book on the blue book is going to be negative 5 newtons. Agreed? Right? So that's how heavy the red book is. All right, so now we're going to say how much normal force does the blue book exert on the red book? Well, that's equal and opposite going up. So I know that normal force is going to be equal and opposite to gravitational force. So that means that my normal force is going to be positive 5 newtons. And now you're going to say to me, but Mrs. Parent, that blue book says 10 newtons. Yes, it does. But remember, that's the downward force of the blue book. So the upward force on the red book can only be as big as the downward force of the red book. If we're looking at the blue book and the, what would you call that, orange book, then the downward force and upward force would be 10 newtons because that's how heavy the blue book is. All right, so what's next here? How much gravitational force do all 3 books exert on the table? Well, let's see. The red one is pushing down on the blue one. The blue, red, and blue one are pushing down on the orange one. The red, blue, and orange one are pushing down on the table. So my gravitational force of the books on the table is going to have to be 5 newtons, negative, plus negative 10 newtons, plus negative 15 newtons. So this is going to be negative 30 newtons, because all of those books are pushing down on each other and ultimately pushing down on the table. All right, the next piece says, how much normal force does the table exert on the books? All right, so now we're going to look in the upward direction. So again, I know that normal force is equal and opposite to gravitational force. So that means my normal force is going to be positive 30 newtons. All right, what do you think? Okay, if you have questions, now's a good time to write them down so that you remember to ask them in class next time. So let's go back up here to the top. Did we identify the effects of Newton's third law, equal and opposite forces? What is Newton's third law? And how is normal force related to weight? So they are equal and opposite. Okay, so here now it's your turn. And just because you know me, I always like to have my formulas handy. We're going to put these two up here. Fg equals mg. And normal force is equal and opposite to gravitational force. Okay? So if I ask you to find the normal force, you got to find the gravitational force first. So you have 3 problems to do here, and they are due the next time you come to class. Make sure, again, that you write down any questions that you have so you can ask them the next time we see each other. Have a great day.